Right, hi guys, welcome back. And today we'll be looking at worksheet number 2, which is basically on your gravitational field as well as your weight itself. All right, so for a start, the question is what is gravitational field? And this again, the answers can be found in your textbook. It's basically a region in space where any object, all right, it will experience a gravitational force, all right, a gravitational force acting on it. Pardon me, but there's a spelling, the typo error over here, so it should be gravitational force. All right. Anyway, moving on. So as you can see in this picture, right? So basically, for the Earth itself, the gravitational field is stronger when you are nearer to the surface of the Earth itself, actually nearer to the center of the Earth itself. So if you are very near to the center when you're on the ground, all right, the field strength will be stronger. And if you are very far away from the center, let's say, for example, if you are in space or you are near the atmosphere, the gravitational field strength will be weaker. Just to clarify, if you're in space, actually you don't even experience you can't feel the gravitational field strength. You're outside of the Earth gravitational field. All right. So that's why spaceship can actually float around in space. Now moving on, and what is meant by gravitational field strength? It basically refers to the amount of gravitational force acting per unit mass. That means per kg. All right, this means per kg. Just take note of that. All right, at a particular point. So the formula to find the gravitational field strength, you just take the weight divided by the mass. All right, and of course that brings us to the definition of weight. So weight is basically just a force of gravity. So sometimes students tell me, oh, my weight is 50 newtons, all right, and my force of gravity is 10. That's wrong. Weight itself is the force of gravity. All right, yeah, essentially this and this is the same thing. All right, but when we talk about 10, we say that the Earth gravity is 10. All right, what we are talking about is the gravitational field strength. All right, this is the one that is 10 newtons per kg. All right, we take it as 10 newtons per kg on Earth itself. Right. Now, so the equation for weight is W is equal to mg, so that's quite straightforward. It's a very familiar equation for all of us. So W stands for weight, and it is measured in newtons. All right. M stands for mass, and is measured in kg. And of course, G stands for gravity, and it depends on the planet that we're talking about. But on Earth, we will take it as 10 newtons per kg. All right. So over here, the four examples given in question 4, I'm not going to go through it because it's quite straightforward. You just have to apply the formula over and over again. All right. The only one that I think you might just want to take note of is this one over here. Because as I mentioned before, right, your mass, this mass must be in kg. All right. So if you are given something in grams, you will have to convert it, as you can see over here. So 10 grams is 0.01 kg, and before you carry out the equation, right? Moving on, question 5, quite straightforward. This time around, they ask you to find G, all right? So actually, for myself, right, I don't remember so many formulas. I just remember W is equal to mg, and if necessary, if they ask me to find the gravitational field strength, then I will make G the subject. So I make G the subject, I bring the M over to the other side, all right? Sorry, let me just erase this first. So when I bring M over to the other side, I get G is equal to W divided by M, weight divided by mass, all right? And that would basically be the same as writing it this way, all right? And that's why you see that I've got my equation there, right? Moving on, so a very common question asking you whether the mass and the weight will change. So the mass is the amount of substance in the body, amount of matter in the body. It doesn't change, all right? It will always be the same regardless of your gravity. It's not affected by gravity, all right? So let's say, for example, I have a mass of 50 kg on Earth. I will have a mass of 50 kg on the moon. I will have a mass of 50 kg when I'm in space, all right? But on the other hand, weight is affected by gravity. All right. So if you go to the moon, because the moon has got a lower gravity, all right, moon has got a lower gravitational field strength. So because of that, the weight will be smaller. And that's why if you go to space, then you will be weightless. All right, because there's no gravity in space, there's no weight. All right, it's as simple as that. And question number 7. Now, question number 7 is a very complex question. All right. Actually, it's very easy, but it's just that it gives us a lot of information. So when you're doing this question, I would advise you to actually be very systematic. Note down all of the information that you're actually recording. So, for example, as you can see over here, I've got at the start, all right, and then at the end. So I find out the values for each of them. The working is very straightforward. The formula, there's only one of them. It's W equal to mg as usual. All right. So I find out what's the start, what's the end. And then after I've done this, I look at the question and they say calculate the changes. All right. So that's why I've got one more column, which is what is my change in mass. So I take the starting, okay, I think there's a typo error here. For the change in mass, right, what I should do is I should take the ending, the final mass minus the initial mass. All right, should be final. It should always be final minus the initial. So the answer should be 13.7 minus 16. And you should get negative 2.3 kg. All right, sorry for the typo over here. There should be a negative sign. All right, so this one, please don't copy down the wrong answer. And the change in weight, of course, as usual, same thing. All right, we should take final minus initial. So your final weight, let's label it as weight final, F for final, minus the weight initial. All right, it should be the other way around. So it's 134.123 minus 156.96. You notice that when I'm doing my working, I tend to use the rough values rather than the rounded off values because that is more accurate, right? And you should get the same thing except that it's negative, so negative 22.8 newtons if I'm not wrong. Do double check, all right? And again, I'm very sorry for this typo over here, all right? Any point in time, if there's anything that you're not too sure, please contact your physics teachers, all right? So this is the final mass and the initial mass, right? And with that, we are done with this worksheet, all right? And I will see you guys the next time around.